Good afternoon everyone. My name is Neha. I'm from IT department. My topic is big data driven networks. Introduction. What are vehicular networks? Networks refer to communication systems that allows vehicles to exchange data with each other and with road infrastructure. These networks are designed to improve traffic efficiency, road safety, and driving experience by enabling the vehicles to make informed decisions based on real-time data. VANETs, Vehicular Ad HOC Networks, a type of mobile ad HOC networks, MANET, where vehicles act as mobile nodes. Vehicles communicate with other vehicles, V2V, vehicles to vehicles, roadside infrastructure, vehicle to infrastructures, pedestrians and the cloud systems, vehicle to everything. Basic VANET architecture showing vehicle to vehicle, roadside infrastructure, vehicle to infrastructures, and data flows between vehicles and the infrastructures. Evolution of the vehicular networks from traditional communication to intelligent transportations. Early stage vehicles operated as isolated entities with no communication capabilities. Traffic management relied on manual systems like traffic signals and radio communication. Transitional stage, introducing of GPS navigation, basic telematics and traffic sensors. Limited data exchange with central traffic servers. Modern intelligent transportation. Vehicle now from dynamic wireless networks capable of exchanging data in real time, making autonomous decisions, interacting with traffic infrastructure, shift towards data driven and the predictive systems. What is big data in vehicular context? Big data in vehicular networks refers to large-scale continuous generation of data from vehicles, infrastructures, and the external sources. This data is collected, processed, and analyzed to enhance the driving safety, traffic efficiency, and autonomous decision making. Sources of vehicular big data: GPS, location, speed and the route, onboard sensors and the units, engine status, brake use, acceleration, traffic cameras and road conditions, congestion signals. 5 V's of big data: volume, velocity, veracity, value. Volume, huge data from millions of connected vehicles. Velocity, rapid data generation in real time. Variety, diverse data types, numerical, video and the text. Veracity, trustworthiness and the accuracy of the data. Value, useful insights for intelligent transport decision. Here is the cycle of the 5 V's of the big data. First one, the volume. Volume consists of the huge amount of data. Variety, different formats of the data from various sources. And the value, extract useful data. And the velocity, high speed of accumulation of the data. Veracity, inconsistency of the uncertainty of the data. Architecture of the big data driven vehicular networks. Big data architecture in vehicular networks enables the real-time communication, processing and the decision making by connecting the vehicles with infrastructure and the cloud system. Flow of the data. Onboard sensors. Onboard sensors is nothing but collects the data from the vehicles, example like speed, location and the engine status. Roadside units are nothing but acts as the intermediaries to relay data between the vehicles and the servers. Edge and the cloud data centers is nothing but performs a real-time data processing and the long-term storage. Decision system uses the AIML to support the traffic controls and the alerts and the autonomous functions. Vehicles. Here is the cycle architecture of the big data driven vehicular networks. First, it includes the vehicle, and the next one is the roadside units and the edge or the cloud. It includes the central traffic system, and the last one is the decision engine. The visual should show vehicles, roadside roadside units by the roadside, and cloud edge servers and connected by the arrows indicating the flow of data. Key technologies used in the vehicular networks. Big data driven vehicular networks rely on a combination of the communication, processing, and the intelligence technologies to ensure the safe, fast, and efficient transport. Cloud and edge computing. Edge devices like roadside units handle the time sensitive data close to vehicles. Cloud handles the large scale storage, analytics, and long term learning. AI/ML models predict the traffic flow, detect anomalies, optimize the routing, learn from historical and the real time data to support smart decisions. MapReduce and Apache. MapReduce is nothing but batch processing of the large data sets. Real time Apache means real time streaming and the distributed data pipelines. Challenges. Despite its potential, implementing big data in vehicular networks faces the several key challenges like data privacy and security, scalability, and the network latency and the interoperability. Data privacy and the security. Data privacy and the security is nothing but sensitive location and identity data must be protected from misuse and the cyber attacks. Scalability is nothing but system must handle the massive data volumes from millions of vehicles without failure. Network latency is nothing but real-time processing in crucial for safety applications like collision avoidance. Interpretability is nothing but standardization is needed to ensure smooth communication across different manufacturers and platforms. Big data driven vehicular networks rely on a combination of a communication, processing, and intelligence technologies to ensure the safe and the fast and the efficient transport. Cloud and edging computing is nothing but edge devices like the roadside units handle the time sensitive data close to vehicles. Cloud handles the large scale storage and analytics and long term learning. AI/ML models predict the traffic flow, detect the anomalies, and optimize routing. Learn from historical and the real time data to support smart decisions. MapReduce is nothing but batch processing of the large data sets. Architecture of the big data driven vehicular networks includes the 4 steps. First one, the flow of data and onboard sensors, roadside units, and the edge and the data centers and the decision system. Big data architecture in vehicular networks enables the real-time communication and processing and the decision making by connecting the vehicles with infrastructures and cloud systems. The flow of data can include the onboard sensors, roadside units, and edge cloud data centers decision systems. In onboard sensors, it collects the data from the vehicle, example like speed, location, and engine status. Roadside units is nothing but act as the intermediaries to relay data between vehicles and the servers. Edge and the cloud data centers perform real-time data processing and the long-term storage. Decision system uses the AI/ML to support the traffic control, alerts, and autonomous functions. 5 V's of the big data. There are 5 V's of the big data. It includes the volume, velocity, verity, and veracity value. where the volume includes the high amount of the data and the variety includes the different formats of the data from various sources, and the value is used to extract the useful data, and the velocity high speed of accumulation of the data. Veracity is nothing but inconsistency of the uncertainty in the data. Volume consists of the huge amount from millions of connected vehicles. Velocity, rapid data generation in real time. Variety, diverse data types, numerical, video and the text. Veracity, trustworthiness and accuracy of the data. Value is nothing but useful for insights for intelligent transport decisions. Big data in vehicular networks refers to a large-scale continuous generation of the data from vehicles, infrastructures and the external sources. This data is processed and analyzed to enhance the driving safety, the traffic efficiency and the autonomous decision making. Conclusion. Recap. Big data enables the smart, connected and responsive vehicular systems. Integration of AI and IoT and the cloud edge to tech powers real-time decisions. Future role. Big data will be central to autonomous driving, traffic optimization and smart cities. Call to action emphasizes the security, scalability and interpretability for successful deployment of big data in intelligent transportation systems. Thank you.